that gives database developers nightmares. What happens when a critical operation, like a payment or a user signup, fails halfway through? Well, a single error could leave your entire database in a tangled, corrupted mess. So today, we are diving into the essential safety net that prevents this chaos, the SQL transaction. So let me ask you a question. If your database could make you just one single unbreakable promise, what would it have to be? For me, the answer is simple. It must promise to never, ever corrupt your data by leaving a job half-finished. And that idea right there is what we're going to call the all-or-nothing promise. See, when you're performing a series of related actions, you absolutely need a guarantee that either every single one of those actions succeeds or not a single one of them takes effect. There can be no middle ground. Just think about a simple bank transfer, right? You want to move $100 from your savings to your checking account. Step 1, withdrawing from savings, works just fine. But then, boom, the system crashes before the money is deposited into checking. Where did the money go? It's just vanished. That is exactly the kind of chaos we have to prevent. And this is precisely where the SQL transaction steps in. It's the official tool for making that all-or-nothing promise a reality. It lets you bundle a whole group of database operations together, and you tell the system, hey, treat all of this as one single indivisible action. It either works completely, or it's like it never even happened. So how do we actually build this safety net in our code? Well, thankfully, SQL gives us this really powerful structure called the try-catch block. It's designed specifically for managing transactions and gracefully handling any errors that might pop up. Let's break down exactly how it works. You know, the logic is actually beautifully simple. First, you start a try block. Think of this as your safe zone. Inside that, you begin a transaction. Then you run all your commands, your updates, your inserts, the whole shebang. If every single one of them succeeds without a problem, you hit the commit transaction line, and all those changes become permanent. But, and this is the crucial part, if any error happens, the code immediately jumps down to the catch block, which should have one simple command, rollback. And that instantly undoes everything. All right, theory is great, but let's see this safety net in action. We're going to try to give an employee a raise, but we're going to deliberately put a mistake in our code, just to see how the transaction protects our data when things go sideways. So here's our starting point. We've got an employee, Ankita, ID number 1, and her current salary is $50,000. Now keep that number, $50,000, in your head. Now, check out the code we're trying to run inside our transaction. We want to update Ankita's salary, but look closely. We've tried to set it to 70,000 divided by 0. As you know, that's a mathematical impossibility, and it's guaranteed to make the database throw an error. And just as we planned, error. The database engine hits that ridiculous calculation, stops everything it's doing inside the try block, and jumps straight down to our catch block. And what's the command waiting for it there? Rollback transaction. And this, right here, is the magic. After that rollback, what's Ankita's salary? It's still $50,000. Exactly what it was before we even started. The failed operation had absolutely zero effect on our data. It's like it never happened. The safety net worked perfectly. Okay, so that's the story for when things go wrong. But what about the happy path? What happens when everything goes exactly right? Let's fix our code and run this transaction again. Once again, we're starting with Ankita's salary at $50,000. This is our clean slate, ready for a successful update. This time, the code is clean. No more funny business. We're just setting the salary directly to $70,000. There are no errors here, so this update statement should execute without any problems at all. So, since the update command completes successfully, the code continues right to the end of the try block and finds our commit transaction command. This is basically us telling the database, yep, everything went perfectly, lock in these changes, make them permanent. And there's the proof. After that successful commit, Ankita's salary is now officially updated to $70,000. So you see the two sides of the coin. A successful operation gets committed, but any failure triggers a complete rollback. All or nothing. Now, let's talk about the scary part. What if we tried to do a multi-step update without the protection of a transaction? This is where data corruption goes from being a possibility to a very real danger. Take a look at this. We're trying to do 2 updates for another employee, Shivani. First, we update her city, which is gonna work just fine. But then, the very next line tries to update her salary using that same divide by 0 error. Since these commands aren't wrapped in a transaction, the database just sees them as 2 totally separate, unrelated commands. And that's the incredibly dangerous difference. That first update to Shivani's city, it succeeds and is saved immediately. It's permanent. Then, the second update fails, but it's too late. The first change is already locked in. We're now left with a partial update and inconsistent data. With a transaction, your outcome is safe and predictable. Without it, you are literally rolling the dice with your data. So let's boil all of this down into a simple, clear playbook that you can use in your own work to make sure your data always stays safe and consistent. Here are the rules of the road. 1. If you have 2 or more database updates that rely on each other, always wrap them in a transaction. 2. Use that try-catch structure to manage them. 3. A successful run means you commit. 4. Any error for any reason must trigger a rollback. And rule number 5, the risk of a partial, half-finished update is just never, ever worth it. And that leaves me with one last thought for you. Take a minute and think about the code you work on every day. Think about those processes that involve multiple steps, like creating a new user and also setting their permissions, or processing an order and updating the inventory at the same time. Where in your projects could adding a simple transaction be the